Hey class. So this is the second to the last lecture for this semester. So we're getting close to the end. I hope everybody is safe and staying healthy. Um, so we're not going to do any computations today. I want to talk a little bit about. Oh, it's tie dye Friday too, right? This is my spring tie dye, so weather's getting nicer. Um, I want to talk a little bit about interpreting correlational data. Okay. Um, I think, correlation type data, when you have survey data, is actually quite common. It's more common than experimental data, experimental research. Um, and it's often reported in the news and in the literature, and people can be fooled a little bit. So I don't want you to be fooled. You need to know this information so that you're cautious when interpreting these type of data. And let me just explain a little bit with some examples. So when we're talking about Pearson's R, this is a measure of how two variables are co-related, right? Correlation. But Pearson's R is a test of linear relationship, okay? Of linear relationship. So one of the things that you have to be careful about, if we have data that are not linear, so we can have something like, let's do this. We'll do arousal level and performance. And what I mean here is, if you're really tired, or if you're hyper aroused, or if you're in the middle aroused, right? We can look at performance, and when we do this, we typically see an inverted U function. So we see people that are tired, like really tired, don't perform very well on a number of tasks, okay? I mean, you can think about taking an exam, for example. If you're really, if you pull an all-nighter, which you should never do for an exam, because you're not going to do your best job even with the information that you know, okay? So don't do that. Your performance is not going to be so good. And if you're really kind of hyper aroused, you've had 4 cups of coffee and a Red Bull to get your wings, you might not perform that well either, because you're too just jazzed up. You can't really perform. But in the middle, maybe you have a cup of coffee, maybe you have a bagel for breakfast, and you're just kind of in this mid-level arousal. So we see a relationship here between X and Y, but the relationship is, in this case, curvilinear. It's curvilinear. The relationship goes like this, right? Okay? So that not very aroused, your performance isn't good. Hyper aroused, your performance isn't good. But here you have this optimal level of arousal. If you were to do a Pearson's R analysis of these data, Pearson's R, and we haven't gotten into this too much because we're just running out of time, but Pearson's R it's a measure of linear relationship. So Pearson's R, mathematically, it tries to find the best fit straight line through here. And the best fit straight line, I don't know where it would be there. I don't know. And your Pearson's R value will come up, and it won't be statistically significant, right? So you might have a Pearson's R value of 0.31, where the critical value is 0.45. And so you would say, oh, there's not a correlation between these two variables. But it's very clear that the correlation, there is a co-relationship, but it's just not linear. It's curvilinear, okay? Pearson's does not test for that. Now, there are statistical analyses that will let you know whether your data points fit this kind of a function, but it's not Pearson's R, okay? So that's why I always tell people when you collect data and you want to see if there's a co-relationship between the two variables, the first thing you should do is do a scatter plot. Because if your scatter plot looks like this, then Pearson's R is just not appropriate. It's not the right test, okay? There are other nonlinear functions. Let's do this, if we can see this. When you do a dose response curve, typically what you're going to see is something that is sigmoidal, something that is S-shaped, okay, like this, all right? Pearson's R value would not be appropriate for this relationship either because it's not linear, it's curvilinear, okay? There are also some graphs where you get data that look like this, where it's an accelerating graph like this, okay? In that case, you know, Pearson's R might approach a straight line somewhere, but it's just not appropriate, okay? So Pearson's R is a test to see if X and Y have a linear relationship. Not, you know, if you have something that's curvilinear, Pearson's R it's just not appropriate. There are tests for these kinds of graphs, but that's something that you might learn in graduate school. Okay, so that's one of the things you have to be careful about. If you get an insignificant R value, it either means there's not a relationship between the two variables, or it means that the relationship is something other than linear. It's something other than a straight line. Okay? There's also, you have to be careful. Sometimes when you have data, so you might have a whole bunch of data points here, and you'd say, well, there's no relationship there, right? That would almost be a zero Pearson's R value. But then if you have a couple of points out here, okay, then what happens is no relationship here, no relationship here. But these two clusters end up like two big fat points. And so the best fit straight line here looks something like that. In this case, you might get what looks like a significant R value, but really it's just because you have this weird two cluster, the separation of two clusters. So you have to be very cautious when you do an analysis where you're looking at a correlation. If it's curvilinear, you can't use Pearson's R. If you have data that looks like this, it's kind of funky, then Pearson's R can make it look like there's a correlation when there really isn't. Okay? But by far, the most important point, and I'm always happy that this occurs at the end of the semester because I think sometimes people remember most what happens at the beginning of a semester and at the end of a semester. One of the things that you have to be extremely cautious about is interpreting a significant correlation. So let's go back. I want to use the example of the alcohol intake. Alcohol intake and GPA, okay? Let's suppose that we had a very strong negative correlation, okay? Let's say that our Pearson's R value is 0.68 and we had 200 people fill out the survey, okay? So this is going to be it's statistically significant. And we have a negative correlation. What does that mean? More alcohol you take, lower your GPA, okay? Let's assume for the sake of argument Very strong negative correlation, okay? And it's like, and so this is our X value, this is our Y value, right? So if the college administration saw these data, they would be like, aha, just what we expected, you know? Alcohol intake really affects students' performance. And so what they might want to do is maybe we'll outlaw alcohol on campus. When I taught it in Pennsylvania, for the first, I think, 8 years that I taught there, we had a dry campus. No faculty could have alcohol. No students of age could have alcohol. It just wasn't allowed. Okay? Well, what the administration is doing in this case is they are assuming that the direction of causality goes this way, right? That high levels of alcohol are causing decreases in GPA. Okay? When you have a statistically significant correlation, all that's telling you is that the two variables are related. That is, as one changes, the other one changes in a certain way. Okay? But it doesn't tell you anything about the causal direction of the relationship. That is, which variable is causing which other variable. All right? For the administration to say, oh, alcohol intake is causing lower GPA, and we're assuming that there is a relationship. Don't get me wrong here, okay? I'm not questioning the data. That is, this is not cynical. I'm assuming that these data are for reals, okay? But to assume the causal direction is the problem, and it's the biggest problem in all of statistics. If I see you guys in the fall and you remember what I talk about today, I will feel like my semester's been completely successful. That's how important it is. So you know what that means in your notes? Asterisk, 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 right? Because let me show you another way to interpret these data. I mean, it could be that alcohol is causing a decrease in grades. But we're gonna submit this report to student government, okay? And the president of the Student Senate might say, aha, just what we expected to see here. Because what I think is happening is that the faculty are causing us to drink. That is, people with lower GPA are drinking more. People with higher GPA don't have to drink more because they're all, excited about their grades. The same data, we're looking at the same data, but look at the causal explanation. I want people to be very clear here, okay? You can have two variables that are correlated. It doesn't say anything about their causal relationship, okay? Could be that alcohol is causing lower grades, or it could be that lower grades are causing alcohol intake, okay? And given these data alone, there's no way that we can make a distinction between these two. Which one is correct? Which one is correct? Now, I'm going to tell you something. You need to take care of yourself, because if somebody wants to interpret it this way, they're going to say, aha, see, this correlation is because alcohol is affecting grades, right? And you'll be shaking your head like, oh, yeah, okay, that makes sense. Well, of course it makes sense. It doesn't mean it's true, okay? Because we could get this kind of correlation if the direction of causality was the opposite way. And it's not just statistics here, folks. This affects how people make public policies. If you think alcohol intake causes decreases in grades, then the appropriate policy is to get rid of alcohol on campus, okay? If you think that a tough grading system is causing students to drink, then the policy would be, let's have a review of the grading system. Let's see if faculty are being too tough on students' grades. The policies are really quite different. To complicate things even further, we're going to give the same data. I'm not changing the data, okay? Let's assume that this is real. And we'll assume that the research was done well, okay? I don't want people to get distracted by like, well, maybe the research wasn't done well. For the sake of argument, let's assume that this research was done really well, and this is what we found, okay? Well, the counseling center might look at these data, and they're going to be like, just what we suspected. Because they're going to say, students have a lot of stressors in their lives, okay? Students have a lot of stressors in their lives. And maybe the impact of stressors on students' lives are what? Causing grades to go down. And what? Causing an increase in alcohol intake. Okay? If there was a third variable causing grades to go down, causing alcohol to go up, then this is what we would see. Okay? And the policy implication here is quite different. If we think that this relationship is being caused by stressors, then what do we need to do as a policy? Well, let's hire some more counselors on campus. We'll hire more counselors. That should help grades go up. That should help people not drink so much. Okay? I'm looking at the same data, folks. That's the problem. And I'm going to tell you right now, people who read the report will have their own interpretation, and they may interpret it this way, or they may interpret it this way, or they may interpret it this way, okay? And they will want to convince you of the correct way to think about this information. It's up to you to take care of yourself. You need to take care of yourself, okay? If you know that these are possible explanations for this kind of correlation, then you can at least bring that to the table, right? And talk to people about it, okay? I'm not being cynical about the research. I'm just saying correlation just means that the two variables are related to one another in terms of how they change. It doesn't say anything about causality. There's a difference between correlation and causation, okay? And some faculty, you may have heard this, they say, correlation does not imply causation. And I'm like, whoa, wait a minute. I'm much more careful when I teach this. I'm saying, yes, correlation does imply correlation. But that's what you have to combat. That's what you have to be aware that, yeah, there's an implication, but it doesn't mean that we know the cause. Okay? Let's use our other example. What was it? Hours of exercise and happiness, right? This is so important, okay? So here's hours of exercise. Oops. I spelled that incorrectly. Hour of exercise, and it's been a long semester, hasn't it? And levels of happiness. And what did we find? We found there was a positive correlation there, right? Positive correlation. And it doesn't matter. I'll just make up an R value. Let's say it's 0.52, and we had 300 people fill out our survey. We know that this is a very strong correlation. The more you exercise, the happier you are, okay? And that's how some people will report it. But what is that doing? That's implying a causal direction, right? That's implying that the number of exercise, the hours of exercise, causes increased happiness. And I'm like, well, wait a minute, not so fast, because couldn't this correlation, again, I'm not going to be cynical about the data. Let's assume for the sake of this argument that the data are sound, that the study was done well and it's representative. I'm not talking about the research design. Let's assume that it was done very well. I would be careful implying that the direction of causality was this way. Maybe people who are in better moods or happier are exercising more. Ta-da! That would cause this kind of a correlation, right? I mean, if you're all depressed and you don't want to feel like doing anything, it's hard to motivate to do exercise, right? And I know there's virtual head bobbing, right? Yes, we agree. Well, but the first explanation, I'm assuming people will be like, oh, well, that makes sense. That makes sense. Well, of course it makes sense because that's what we found with our data. Hours of exercise causes more happiness. But I'm saying the alternative is maybe happiness, your level of happiness causes you to exercise more, right? Both of these can explain the same correlation. So when someone interprets a correlation, you should say, hey, listen, wait a minute, and apply this kind of thinking. Maybe it's the opposite direction. And then, so here's my X variable, my Y variable. I'm always thinking about a Z variable too. Okay? Maybe people who are generally more healthy, okay, they exercise more and they're happier, okay? Or maybe the number of friends that you have influences how much you exercise. You got, exercise buddies, right? And that influences happiness as well, okay? So I always want you to apply. Listen, here it is. It's easy to remember if we do it this way. Apply this test when you're given correlational data. Apply this test. I wonder if X causes Y, or maybe Y causes X, or maybe there's some third variable that causes both of these to change so that we get this kind of correlation. Okay? And I have tons of examples. I mean, I heard a news report a couple of years ago, and this was actual research, and it was with elderly people, and here's what they found. Hours spent in a casino. For elderly folks, the hours that they spent in a casino was positively correlated with some kind of health index that they used, okay? Positively correlated with health. What does that mean? I mean, I want you to understand what that means, right? There's a positive correlation. So the more time they spend in the casino, the healthier they were. X and Y, right? And I remember hearing this on the radio. It was a news show, and they were saying, wow, this is really kind of weird. So the number of hours you spend in a casino influences your health, right? What are they doing there? They're assuming that this is the cause. They're assuming that this is the causal direction, right? That the hours you spend in a casino positively impacts your health. And they're talking about this 5 minutes, 7 minutes. And I'm going nuts in the car because I'm like, oh my God, my students can do this. What about considering the opposite direction, right? What about considering the opposite direction? That is, people who are elderly folks who are healthier are more likely to spend time in a casino. And it's like, oh, yeah, that may be the cause of the correlation. Again, I'm not questioning the correlation, although you can do that too. But there's research that is done very well. If it's correlational, it does not address causal relationships. Everybody with me? Correlation does not mean causation. Correlation does not mean causation. It just means that two variables are related to one another in terms of how they change. Could be that hours spent in a casino cause people to have better health. It could be that. I'm not negating this. I'm not negating this, but I'm entertaining this. Everybody with me? I'm not saying this isn't the way. Because it could be that way. It could be that way. It could be some third variable. Hours spent in a casino associated with increases in health. Maybe going to the casino enhances your health. I don't know how that would be. Maybe they're pumping oxygen into the casino because they want people to stay there longer, right? I don't know. But it could be that older people that are in better health go to the casino. I mean, we're not going to take my grandfather with a wooden leg who's on oxygen, to the casino. We're going to take my grandmother who's part of the Red Hat Society, and she goes on trips with her friends and, goes to the casino. You see what I mean? Can we think of a third variable? Can we think of a variable that might be related to better health and might be associated with more hours spent at a casino? Can we think of a third variable? I'll give you a hint. What do you need to go to a casino? Money. Yeah, I mean, it could be that these two things are not causally related at all, but that if you have more money, you're going to get better health care. And if you have more money, you have more disposable income for a casino. See what I mean? Okay? Always, when you're interpreting correlational data, apply this model. Apply that model, okay, for possible causal explanations for a correlation, okay? Correlation just means that two variables are related. It doesn't tell you what the causal reason for that is, okay? Let's do another one. I mean, this is so important. Of course, it's going to be on the exam, of course. I mean, when a professor says something is that important, you got to know it, right? So let's do this study. Let's do this study. We're going to ask people for our x variable. How many friends do you have? And here I'm not talking about Facebook friends or Twitter, Instagram friends or whatever followers. I'm talking about how many friends do you have? And I like this example because it brings us back to a little bit of psychology and research. We need to operationally define what we mean by friends, right? I mean, because I have lots of acquaintances. I know a lot of people. I'm a very social guy. But people I call friends, what is special about a friend that's different than just an acquaintance? I think that Jerry Seinfeld had this right years ago on the Seinfeld show. A friend is somebody that's going to help you move, right? I always love it. People like, hey, I'm going to move this weekend to another apartment. Can you help me out? And I'm like, I would love to help you out, but I'm getting a tooth pulled or what, Moving people is sometimes hard, especially if they got a futon or if they got a piano. I mean, it's just. But somehow let's, have people self-report. How many real friends, true friends do you have? Okay, so that's going to be one of the things that we're going to ask. So some people have 2 friends. Some people have 8 friends. Some people might say 0. I mean, that would suck. Some people might say, well, I really only have 1 true friend. Some people might say 10, Then we're going to do, we're going to administer the Beck Depression Inventory. So this is a pencil and paper test, the Beck Depression Inventory, okay? If you take clinical psych, abnormal psych, you probably study this. It's a pencil and paper test that measures level of depression, okay? So this will be our Y value. So everybody's going to tell me how many friends they have, then I'm going to see how depressed they are. So here's the first question. What kind of correlation do you think we would find if we did this study? Do you think it would be a positive correlation, a negative correlation, or no correlation at all? Well, yeah, I think that what we would see here, if we really did this research, is probably a negative correlation. It's probably a negative correlation. So the more friends you have, the less depressed you would be. Okay? I mean, that would be my guess. It would be an interesting study to do, right? This is a kind of a good clinical psych study to do. But I would expect this. And let's, for the sake of argument, right, let's say that somebody did this study and they found that the Pearson's R value was negative 0.47, and they had 235 people in the study. Because this is sort of kind of a typical survey study, right? If we looked up this R value, right, how many degrees of freedom do we have? Degrees of freedom would be 233, because remember it's n minus 2 for a correlation, just a little reminder. If we compared this to a critical value, this would be wildly significant, okay? So there's no doubt that this is the relationship that we have for the sake of argument. Now, don't fall into this trap. It's very, very easy to fall into the trap. You'd say, oh yeah, of course, because people with more friends are going to be less depressed. And people with fewer friends are going to be more depressed, right? What are you doing in that case? You're implying this causal direction, okay? And I'm like, whoa, 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 wait a minute. Let's apply our system here. Maybe X causes Y. It could be that this is the cause. I'm not negating that, okay? It could be that number of friends influences your level of depression. But I want you to entertain this as well. Your level of depression might influence the number of friends you have. I hate to say it, folks, right? I mean, we all have met people that are just like, wow, Debbie Downer or Danny Downer or whatever. It's like you meet this person and they're like, I'm so depressed, blah, blah, blah. And you're like, oh my God. I mean, everybody gets depressed, folks. I get depressed. If we were in class, I would tell you, I went to counseling for depression for about 1.5 years and that was when I was 35 years old, because I was having recurring episodes and I needed to address it. I needed to figure it out, right? But sometimes when you're around people that are always depressed, it's tough to be their friend, right? And so it could be people who are more depressed have fewer friends, or people who are less depressed have more friends. Okay? That's a possibility. And as soon as you start thinking about it, they're like, that might be true. And in fact, there's something called reciprocal determinism. It may be that number of friends cause depression, and your depression causes number of friends, and number of friends right? That's getting even more complicated. Just think about this as two possibilities. Hey, remember, we got to think about a z variable too, right? A z variable. Well, maybe, I know this doesn't happen in college. I know it doesn't happen in college. I'm just kidding. I'm winking. But maybe attractiveness, unfortunately. So if you're less attractive, that's going to cause more depression and cause fewer friends. So maybe your level of attractiveness is influencing both of these. Okay? Or maybe your social skills, right? Your social skills. So it may be that your social skills are causing you to be less depressed and giving you more friends if you have good social skills, right? Or if you have poor social skills, you have fewer friends, and then you have more depression. I'm always thinking about this third variable possibility. Now, given correlational data alone, you can't decide which one is the causal direction of these variables. I'm assuming that this is true. Everybody with me? I mean, I don't want to belabor the point too much, but always apply this strategy when you're trying to think about potential causal relationships. Okay, it doesn't mean the correlation isn't there. It's how you're going to interpret this. Okay, it's the number one thing that you need to protect yourself. Because I'm going to tell you one thing right now. If somebody did this study, they will tell you how they're going to interpret it. And it will be reasonable. And you'll be like, oh, okay, a little bobblehead because you forgot all your statistics, right? You say, well, wait a minute. Maybe it's this way, but it could be this way. The causal relationship, or it could be some third variable. Okay? So we need to be very careful. And of course, I'm going to ask you a question like this on the exam. I mean, I don't want to telegraph my exam, but if the professor says it's this important, then it's that important. Always remember to apply this. And people aren't going to say to you, hey, remember, this is correlation. Be careful about how you interpret it. That's not what's going to happen. They will interpret it for you. They will interpret it for you. And it's up to you to be skeptical, right? To be prepared. I don't ever want people to be cynical. Cynical's not nice. Skeptical, absolutely. Okay. Let me do one more example. Let's see. Sometimes people will say in the literature, if you do drugs, people who do drugs are more creative, right? Like you're doing hallucinogens or something. And we'll look at creativity, right? So maybe we'll find a positive correlation here. By the way, I don't think you would, but for the sake of argument, let's assume we saw a positive correlation. Now, of course, people that want to do drugs are going to be like, oh, yeah, see, the drugs cause creativity. Are you ready to apply the XYZ? Maybe people who are more creative are the ones that are trying drugs. Oh, it's like, if people who are more creative are doing more drugs, we're going to get a positive correlation, right? If people who are doing drugs, if that causes creativity, then we're going to see a positive correlation. So if we see a positive correlation, I don't know which one of these may be true. What about a third variable? Anybody? Guess what? I mean, you better have some free time if you're going to do, powerful drugs, right? People who have more free time maybe are more likely to do hallucinogens. People with more free time, I mean, you need time to do creative work. Okay? I always find it fun and challenging to try to come up with a potential third variable. Okay? It's easy to go back and forth this way. Can we come up with a third variable, right? So always apply this XYZ. Always apply this XYZ. Now, there's a corollary to this too that makes it even more difficult. That's why, you're in college, folks, so this is a complex idea. I think I've told you before in class, if you didn't want to learn about complex things, then your education is done because you've got all the basics in high school. College is about these kinds of complexities, okay? So here's another thing that makes it difficult. If X causes Y, then you will see a correlation between the two. Listen carefully, okay? If X causes Y, you will see that they're going to be correlated. But it's not vice versa, right? If X causes Y, you will see a correlation. But just because you see a correlation doesn't mean that X causes Y. Let me say that again. If X causes Y, you will see a correlation. But just because you see a correlation doesn't mean that X caused Y. Listen, let me give you if it rains out, then the sidewalk gets wet, right? If it rains out, the sidewalk gets wet because the rain is causing the sidewalk to get wet. But just because the sidewalk is wet doesn't mean it rained. Could be that somebody hosed it down. Could be that the big dog just came by. Okay? It's the same. That's the same kind of logic. Everybody should take a logic course. If X causes Y, we will see a correlation. But just because we see a correlation doesn't mean that X causes Y. It could be that Y causes X, or it could be some third variable causes both, and these aren't causally related at all. Okay? So just be careful, and it's up to you to be careful. Most people are going to try to sell you an idea, right? And it's up to you to say, well, wait a minute, what about this way? Okay? Or maybe there's a third variable. Very important stuff. Has nothing to do with math, right? It has to do with psychology. It has to do with statistics. It has to do with research. It has to do with considering the relationship between variables, and all that stuff. So we have one more class to go, and on Monday, and then we'll be done with the semester. What I'm going to do is then distribute the final, and you can take the final at your leisure, when you can fit it in your schedule. I will have a date when you will need to submit that final to me so I can get the grades in and all that stuff. Okay? But we're not going to, I'm just going to send it out like I did the last time. You guys can send me the file back. Please put your name as part of the file name. Okay? Because otherwise I'm going to get, 50 files that say 4th exam or whatever. If you have any questions, please email me. Hang in there, folks. We're almost at the finish line, and please take care of yourself and be safe. So I'll see you on Monday.